All right, guys, we're going to go over two more graphing examples here that will hopefully help us really get the hang of this sine and cosine graphing. And like we've done in the past, I'm going to use a T-chart. And you really just take your time, and you need to know those parent points. So just kind of have them nearby, or I'll have them on here so you can use them. So for cosine, this first graph is a cosine graph. I'm going to write out my parent points for x and y. And the x's are always the same to start. We start at 0, and then we go up by pi over 2. So pi over 2. Instead of writing pi, something you could do if you want to is you could just actually count by pi over 2. So pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, which would be 2 pi at the end. So our 5 key points, cosine starts at 1, and then we go through 1, 0, -1, 0, 1. So it starts at 1, goes down to 0, down to -1, and back up. So it's like a bowl. And then when we draw that on the graph. Okay, now we're looking at our equation for the changes. So anything that's not in the parentheses, so this -2 is going to be a change to y, and that's exactly what we do to y. So for y, we're multiplying all our values by -2. Now our x values actually come from whatever is in parentheses, and that is the opposite. So we're going to do them in order. The first is this 2. So that is going to take all of our x values and multiply them by a half. We're taking the opposite. Instead of multiplying by 2, we're multiplying by a half, or dividing by 2 if you want to think about it that way. So I'm going to do them one at a time. I'm going to do 1/2 x. After we do that, so we said this 2 multiplies by a half. We do what's all the way inside the parentheses. We're going to add pi to it. So first thing I'm doing, I'm taking all the x columns, multiplying by a half. When they're fractions, we just multiply the denominator, right, by 2. So this is still 0. This will be pi over 4, 2 pi over 4, 3 pi over 4, and 4 pi over 4. And it's up to you if you want to simplify them or not. I'm actually going to leave them. And then adding pi to them, since all our denominators are denominator 4, I'm going to write this as denominator 4. It'll be 4 pi over 4. So this guy will be 4 pi over 4. This will be 5 pi over 4. And we see the pattern after 1 or 2, hopefully. I like to do this way with the common denominator, so it's really easy to decide what I want my x-axis scale to be. So I'm going to scale my x-axis now. I'm going to say one line is pi over 4. So then 4 pi over 4 will be 4 lines. So 1, 2, 3, this would be 4 pi over 4. I'm not going to label every line. I know this one will be 5 pi over 4, 6, 7, maybe I'll label 8 pi over 4 as the other one. And then we're going to put all of our points in. So 4 pi over 4 is 0. 5 pi over 4. Oops, I messed up my first point. 4 pi over 4 should be -2. I'm going to actually highlight the ones I'm graphing, or the green ones, but the outside columns. 5 pi over 4 is 0. 6 pi over 4 is 2. 7 pi over 4 is 0. 8 pi over 4, -2. And there's one curve, one period of our cosine graph. Now, if you like to keep going, we'll just keep this pattern. So every one line, I'm going either back to the middle and then keeping it going. So it's always this like Loch Ness monster shape, up and back down. And once you do a bunch, some people like to fill in the whole graph, some people like to just do a couple, but I will put arrows on the end because it does go on forever. All right, so that's our first one. I'm going to do one more example here. And it's this guy, 3 sine 3x plus 4. So now I need the key points for sine. And the x's are the same. I'm going to, again, keep the common denominator. And the y's, I'm going to make this guy x, start at 0. And then up, back down, all the way down, back to 0. All right, so anything outside. So the 3 and the 4 are all y changes. I think these are usually a little bit simpler, so I'm going to do these at the same time. 3y plus 4. And then the x's, we only have one change here. That's going to be the 3, and it's going to be 1/3 times the x's. So 0, pi over 6, 2 pi over 6, right? For us, this is essentially just going to change all of our denominators. All right, and then we're going to start graphing. Whenever there's a number on the end, I call that the midline, and I like to draw that onto my graph. So I know like where the graph will be centered. So this one, our midline's up at 4, 1, 2, 3, 4. So we know our graph should always go evenly above and below this. And now I'm going to graph these points. And I see we're kind of like counting by pi over 6's here. So I'm going to make one line pi over 6. And then I'll just mark every couple. So this is 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. Right? You decide how many you want to mark, but mark at least one. All right, and then we'll graph. So we've got 0, 4, pi over 6, 7, 4, 5, 6, 7, 2 pi over 6, 4, 3 pi over 6, 1, 4 pi over 6, 4. So there's one sine curve, and that's like our snake shape, right? Instead of cosine is like just the cup, just the valley. Sine goes up and back down. And I'll just do a couple more to keep this pattern going. So going above the line, back to the line, down, back to the line. So this would be 3 periods, 3 cycles of this graph over there. As long as you have one, you're good, but I usually like to extend it a little so we know it goes on forever. All right, guys, that's our practice for today. Try out the quizzes, take your time, and I would definitely graph some of those problems.